Welcome back, y'all. Today we're going to be looking at scientific notation. In this video, we're going to look at scientific notation. This is 4-3, scientific notation, a way to write very small or very large numbers. So what you should do when you're going through these videos and trying to learn from them is stop the video about right now and copy down what you see or the example problems. Make sure you know the title of what you're doing and make sure you understand the directions that you're being asked and the vocabulary in it. And so that when you need to refer back to something, you have it on your paper and you can refer back to your paper. So I would stop the video right now and I would copy down some of this stuff, and then you can fast forward to the end to see if you know how to do it or try it yourself. And if you get stuck, then you can thoroughly watch me do the problems. But watching is not going to make you good at math. If watching made you good at math, some of us might be good at basketball or football because we watch it so much. Watching is only going to make you good at watching. Doing is what's going to make you good at doing. So here we go. Stop the video now and copy everything down and then turn back on in a few minutes. All right, here we go. Scientific notation is a way to write very small or very large numbers. And we use specific format. We use it a lot in science class. So the format we have here is that you have one digit, then you have your decimal point, and then you have as many decimals that you need. Okay? Now, that one digit in the very front cannot be 0. That's very important. And you can have as many digits as you need after the decimal point as long as there's no trailing zeros. Okay? And then you have an exponent. And that's why it's in this chapter, because we deal with exponents in this chapter. And so exponents, when the exponent on the 10 is positive, then we're looking at a really big number. And when the exponent on the 10 is a negative, we're looking at a really, 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 really small number. Okay? And a lot of people think that the decimal point or the exponent up there is the same as the number of zeros. This is not the number of zeros. Okay? It's not the number of zeros, because some of y'all have done that before, and that's what y'all think it is. It's not the number of zeros. Okay? This is the number of place values, number of places, or the number of place values. Okay, each place value is a power of 10. Okay, so that's not the number of zeros, it is the number of place values. So remember that. Okay, so our first group of problems, we're going to determine, first of all, if it's in scientific notation. If it is, great, we'll move forward. If it's not, we're going to rewrite it so that it is in scientific notation. So this first one, if we look at it, it is in scientific notation. And I'm going to write SN for scientific notation. Okay, it is. Yes, you have the one digit, you have as many digits as needed, and you have the exponent there. And so that one's in scientific notation. But the second one is not in scientific notation because our first digit is 0. Okay, and so this is where we have to learn how to move this decimal point around to make it where it is. To have this in scientific notation, we've got to have a non-zero digit and then the decimal. So technically I need to move that decimal to the right one place. Now afterwards is a bunch of zeros, but I don't need those. So technically I can not have the decimal for this. So I have a 7 times 10, but wait a minute. Remember, the exponent represents decimal places, and I changed the decimal place. So how do we do this? Well, we have a little trick, a little mnemonic that we're going to use. It's LARS. If you move to the left, you're going to add 1 to your exponent. If you move to the right, you're going to subtract 1 from your exponent. So I moved it to the right 1 place. So I'm going to subtract 1 from my exponent. So for scientific notation, I'm going to have 7 times 10 to the 7th for that one. All right, so now let's look at the next one. Again, this is not scientific notation. So I've got to move it. So this time my decimal needs to be here. So that's 1, 2, 3, 4, 5 places. Okay, so it'll be 7 times 10. Now, there wasn't a 10 before, right? So the decimal, so we'd only need to 5 because it would have been 0 places, and so that would be 5. Okay, now this one. This is a large number. I'm sorry, this is negative 5. My bad. Wait a minute. I don't know what I was thinking. This is a small number. Remember, small numbers take negative exponents. This is a small number. Okay. This one over here is a large number. So we're going to have 1.3, okay, because the decimal can go here. And we've got a large number. We're going to have a positive exponent. What's our exponent going to be? Well, it's the number of places, not necessarily the number of zeros. So let's count the places. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this would be 1.3 times 10 to the 10th power. I'll give myself a little more. 1.3 times 10 to the 10th power. Right. Now, this last one, it's a small number because it's a negative, so we're small number. Make sure you learn that. And so the decimals here, we need to move the decimal to there. So that it says 2.7. So 10, I moved to the left, so I need to add 1 right there. So it would be negative 2. Now the little large thing doesn't really work sometimes when you have numbers that are in standard form. This is not scientific. This one's not scientific. But when they're in standard form, this is standard form. So just be careful. All right, let's do another one. Let's do something else. So these we're going to write in standard notation. Okay, so they're already in scientific. We're going to write them in standard. This one is big. Stop the video if you need to copy these down, and then start back up. This one is big, and so I'm going to put my zeros at the end. So I'm going to try 8 zeros, but I don't know if I'm going to need 8 zeros or not. Right? Because that number is not the number of zeros. It's the number of places. So now my decimal started here, and so I'm going to count to 8. 1, 2, 3, 4, 5, 6, 7, 8. Ooh, I did need these 2 zeros. You see, it's not the number of zeros, it's the number of places. And so this is the correct answer. It's going to be 680. Whoops. 680 million. That's standard notation. Okay. Now this one is a really, really small number. This one's small because my exponent's negative. All right. And so small number, I'm going to put the zeros in front. I'm going to do 4 zeros, but that doesn't mean I need all 4 of them. Let's see how many I need. So there's my decimal right where it was, and I'm going to count 4. So there it is. So it should be 0, then point, 1, 2, 3, 5, 4, 7, 1. So that would be in standard notation. Okay, so now we're going to multiply. Now this is where we go to our rules. Remember, when you multiply, you add your exponents. This was one of our exponent rules. When you multiply, you add your exponents. So this is going to be real easy to write in scientific form. I'm going to multiply the 2 times the 2, and that's going to give me a 4. And then I'm going to add the 5 and the 3, and I'm going to get 8. So that's my scientific notation. That's my scientific answer. My standard notation answer, this is a big number. It's a big number. I'm going to put the 4. I'm going to put 8 zeros. But I don't think that's right. It might be right, but I don't know that it's wrong. I don't know that it's right. It is right, actually. And then just count my decimal places. Make sure I did 1, 2, 3, 4, 5, 6, 7, 8. Yes, that is right. So that's scientific. This is standard. All right. This next one, we're going to, again, multiply. So I'm going to multiply the 7 and the 4, and I'm going to get 28. And then I'm going to add my exponents. So the 5 plus a negative 2 is a positive 3, but this is not in scientific notation. It's not, because I've got to do that one digit. So that moved to the left. And remember Lars. Moved it to the left. I'm going to add one more. So 10 to the 4th. Okay, so this is scientific. And now how big is this? What is this real number? So I will put 4 zeros, but I don't know if I need them all. Let me count. 1, 2, 3, 4. No, I didn't need all of them. Didn't need all of them. That's standard. Calculators can help with this, and I really don't mind if you use calculators for this. So go ahead and get you one and try playing with it. All right, this is a little long on the video side, but I only have this. This is my last slide, so I'm going to push through. Push through, push through. Okay, so remember, we're going to divide this time. When we divide, remember when we divide, we subtract the exponents. Okay, so let's do that. So I'm going to divide the number. 6 divided by 3 is 2. And then I subtract my exponents. All right, so I might need some scratch work. So that's negative 3 minus a negative 3. That turns into 0. All right, and so 10 to the 0 would be what that is. Well, we learned that 10 to the 0 is 1. So this is the scientific. But then standard would just be 2. I wonder if that's the way it is on your homework. I'm going to have to look back because I don't remember seeing it like that before. Okay, the next one we're going to divide 9.6 by 4. Use your calculator if you need to. I think it's 2.4. Okay, so I just did the division, 9.6 divided by 4. I just did that on my calculator. And then I'm going to subtract, I think that's a 2. We're going to call it a 2. Let's get that purple in there. Let's call that a 2. That way we can know what it is. Okay, and then we subtract the exponents. So that's going to be negative 3 minus 2, which is actually going to be negative 5. That is scientific notation. And then if I want to make it standard form, this is a small number, so I'm going to put zeros in front. Small number, you put the zeros in front, and let's count. 1, 2, 3, 4, 5. 5. And so that is standard form. All right, now this next one is kind of tricky. 4 divided by 16 is 0.25. 0.25. Okay, and then subtract my exponents. So 7 minus 2 is 5. But again, this is not scientific. Remember, scientific, I need to have the 2.5. So again, back to Lars. I moved it to the right, so I'm going to add 1 to that exponent to make it a 6. So that's the scientific. This is a big number, positive exponent, big number. So I'm going to put my zeros at the end. I don't know if I need all 6 of them or not. I'm going to count. So I'm going to count 1, 2, 3, 4, 5, 6. Nope, I didn't need that last one, so I'm going to erase it. And so that's the standard form. Okay, now this very last one, the calculators with scientific notation. This is the way many calculators use scientific notation. They just put an E on the display. They don't have the times 10 to the anything, and people really freak out. But what this means is 15 times 10 to the 5th divided by 3 times 10 to the negative 1. Okay, that's what that means. And so that would be 5, because 15 divided by 3 is 5. And then we've got to subtract 5 minus negative 1. Change will be 6 times 10 to the 6. And so on the calculator, the answer would be 5E6. That's what it would look like on the calculator. Okay, y'all. Woo! That was a long video. I hope it was okay. If you have any questions, you know how to get in touch with me. Great job. It's just math, y'all. You can do it.